Let E be a non-empty set. This E is said to be bounded above if there exists capital letter M such that for all x in E, the x is always less or equals to M. For example, if E is a set of x such that x is less or equals to 1, in this particular set, we have upper bounds. And what are the upper bounds? The upper bounds are 1, 2, 3, 4, and numbers between them. Number between 1 and 2, number between 2 and 3, 3 and 4, and so on. So all these numbers, they are not part of the set. They are not part of the set because the x is less or equals to 1. X is taking the value of 1 and something that is smaller than 1. So anything 1 and above, they are not part of the set. And all these numbers here, they are called the upper bounds. And since this particular set has upper bound, we can say that E is bounded above. Is bounded above. If there exists a real number K such that X is greater or equals to K for all X in E, then we say that that particular E is bounded below. Let me use example to illustrate. Like if my E is equal to set of X such that X is greater or equals to, let's say, -1. Obviously, we have -1 less or equals to X. That is, this particular set, it has the lower bounds. And what are the lower bounds here? The lower bounds here are -1, -2, -3, and the number between them. That is, it's bounded towards this side. Unlike the bounded above, it's toward this side. But this one is this side. So since in this particular set is having the lower bounds, then we say it's bounded below. And if a particular set, like here we are talking about E now, if that particular E is bounded above and also bounded below, then we say that particular set is bounded. But to make it easier, like we can say that a set is said to be bounded if there exists a particular, let's say, M. Okay, let me say E. Let's say E is a set. We can say this particular E is bounded if there exists M such that the absolute value of X is less or equals to M for all X in E. So this is still the same thing with what we have done before. Okay, if I have M such that the absolute value of X is less or equals to M for all X in E, then consider that this particular E is bounded. It's bounded. Let's relate to what we have discussed before. You know, when we say something is the absolute value is less or equals to this, we are saying that either X is less than M, less or equals to M, or minus X is less or equals to M. And considering this one, you can say that minus M, or let me say X, is greater or equals to minus M. As in, if I negate the two of them, as in negating both sides, this sign will change to greater than, then this becomes positive, it becomes negative. And this, it is the same thing as minus m less or equals to x. As in, if I change this one here, the sign will change to what? To less or equals to. And continue with this statement here, since x, this is x, is what? Less or equals to m. You can see that obviously this what particular x is inside minus m, so comma what? M, which means it has both what? Upper bounds and what? And lower bounds. Just like what we discussed here. Oh, there's a number exists so that this is less or equals to this. Then another number exists so that what? This is greater or equals to this. So immediately we have this particular definition. As in, they ask what is boundedness, or when do we say a set is bounded? You can say that okay, there will be a particular number. That is, there should be a number inside a real number, such that if I take the absolute value of x, will be less or equal to that particular number for all x in the set, then that particular set is what is bounded.